A quadratic is given by the equation y equals kx squared plus 2x minus k, and aligned with equation y equals kx minus 2. K is a constant. We need to find the set of values of k for which the curve and the line do not intersect. You have a quadratic and a linear. This is a linear and quadratic system. To find the values of k for which the curve and the line do not intersect, we equate these two equations to obtain a quadratic equation. And since they do not intersect, the discriminant must be negative. We let kx squared plus 2x minus k equals kx minus 2. Now we move everything over to the left side. Kx squared plus 2x. Kx, when it is moved to the left, it becomes negative kx. And when we move 2 to the left, we have positive 2 minus k equals 0. We can group these two together so that kx squared plus 2 minus kx plus 2 minus k equals 0. From this quadratic equation, A is k, B is 2 minus k, and C is 2 minus k. The line and curve do not intersect when the discriminant is negative. B squared minus 4AC must be negative. B squared is the square of 2 minus k, minus 4a is k, and c is 2 minus k. This must be negative. Look at the common terms here. We have the square of 2 minus k, and we have 2 minus k. We can factor that. So we have 2 minus k, and we are left with 2 minus k minus 4k. This is less than 0, so that we have 2 minus k. 2 minus k minus 4k, that is 2 minus 5k. Find the zeros and use a sign diagram. When we set 2 minus k to 0, k is 2. And when we set 2 minus 5k to 0, k is 2 over 5. And we can draw a sign diagram from these two values. We have 2 over 5 and 2. And for the first linear factor, 2 minus k, so we have 2 positive here and a negative. And 2 minus 5k, this is positive, and the other two are negative. Find the product of signs. So we have positive, negative, and positive. And we need to solve for the discriminant less than 0. So we need a negative sign. And from here, we can see that k is in between 2 over 5 and 2.